Now, this is an LGU barrel, breech end, and you can see that the barrel is just machined square on the end. It doesn't have what we would call a conventional leading for a Springer, which is a countersink that is placed around here. You normally have a countersunk before the end of the barrel, and on this barrel, I can just get right, the rifling is machined out for a small section just there, and that means when you push the pellet in, the pellet sits flush with the end of the barrel, but the pellet doesn't actually seal in the barrel. It moves very easy. And what this means is, because it doesn't have that chamfer that's cut for the skirt to sit against just here, the action itself needs a smaller transfer port, and that's to choke the pressure back so that the pressure builds higher within the compression cylinder. Now, normally a pellet pushed in the end of a barrel acts as a valve, and the action of bending over the skirt so the pellet can let go, so squeezing the skirt inwards so that the pellet can then travel down the barrel, that allows the pressure to build higher. But because an LGU is machined more like a PCP and is straight and you can push the pellet straight into the barrel, you have to choke that pressure by using a small port. Now, if you don't use a small port and you enlarge the port, you can actually make soft pellets fly with less energy because they just let go way too soon. You actually need a smaller port for the likes of JSB pellets to actually hang on long enough for the pressure to build behind them, so that when they do let go, the pressure is high enough so when it expands, it gives the pellets a full shove. They hit full speed down the barrel. I'll just move the camera. So there is basically, this is a TX barrel. Good drawing, but you'll get the idea. So you'll see that there's a chamfer cut on the end of the barrel, and when you push that pellet in, that skirt, which is wider than the nose of the pellet, actually sits against that chamfer and forms a seal. So when the pressure builds in the area behind it, it has to physically bend that skirt over before the pellet will let go. So the pellet slowly gets squeezed into the barrel as the pressure builds behind it, and then eventually will let go and travel down the barrel. That makes that allows for a larger transfer port, which increases flow, which can increase efficiency. Now, this is an LGU barrel. Now, obviously, I've omitted the rifling, but the rifling sticks in a little tiny bit. But this end piece here has just been machined round. So you effectively thumb the pellet into the barrel and it sits flush. And you've already bent the skirt over slightly. So this pellet now is not held as fast or as solidly as this pellet, which means that this pellet will let go and start traveling down the barrel before that pellet would. Now, what you can do is you can machine a little tiny chamfer, which I have done on my LGU here, but because the end of the barrel here has already been slightly machined, it can't be anywhere near as pronounced as this. That can increase efficiency, and I did see a nice gain of around 20 feet per second by doing that, which allowed me to back off the spring, etc. But if you now, if you run this barrel standard, but you open the port, it can actually make, not always, but if the port is too large, it will make soft pellets like JSB pellets travel too quickly. They will let go too fast within the firing cycle. And you can end up with a situation where adding preload actually slows the pellets down, because the pressure, the flow is too high. The pellets, you're just causing the pellet to let go sooner and sooner without getting the pressure build behind it to give it that full shove down the barrel to hit full speed. So it's important that an LGU, the compression cylinder that sits behind here, the port isn't too large because that's effectively choking back the flow, which allows the pressure to build higher here, and eventually the pressure is high enough, the pellet then lets go, and because the pressure is still it's still rising faster because the port is choked, that means that the air behind the pellet, even though the flow is slightly lower, the pressure is higher, which means it gets a full shove. So it's important you don't mess with the port too much. Now with small piston conversions, it's really important the effect becomes even more pronounced, and I made the mistake originally of using a too large a port here, which would cause, because the pressure is so much higher with a 22 or a 21 mil conversion, the pellet just lets go way too quickly. But it would work well with a harder pellet like a Superdome or a Field Target Trophy. Now, if your chosen pellet is a Field Target Trophy or a Superdome, then running a larger port can actually be beneficial, because then you can increase the efficiency and you can back off on the spring and run less preload, so a softer firing cycle, and still get decent power. But your mechanical energy using a JSB pellet might be only 9.8 foot-pounds, where a Field Target Trophy might be 11 foot-pounds. Onto another thought now, as we're all moving into lead-free eventually, I'm beginning to think this may suit lead-free pellets better, because they're traditionally, the material is stiffer and doesn't deform as well. So lead-free might have a harder time with this kind of setup, because the skirt doesn't deform as well, because the skirt itself is quite hard. So running an LGU stroke PCP setup might benefit with a slightly larger port behind it, which would mean a softer shot cycle, because we could run less spring, and at the end of the day, a lighter lead-free pellet might benefit from that. I'll test it, I'll play around with it and see if that's the case. But getting back to lead pellets, it's important, if you're going to tinker with an LGU, there's a reason why the port is small. Don't go too big. I used to make the mistake of going too big. Not anymore. I leave them well alone now at 2.6 millimeters. I found between 2.6 and 2.8 millimeters is about optimum, unless you change to this design. If you change to this design, so you remachine the barrel, so you alter the shoulder length and take 3 millimeters off the end of here, and then you can machine a proper lead in. If you do that, then you can run a larger port like a TX, because remember, a TX has like a 3.7 millimeter port there, and an LGU has a 2.6 millimeter port. Now the one in the middle I haven't drawn is a Viarac. They have normally around 2.8 millimeter ports. Some had 3 millimeter ports, but it's still much smaller than a TX. Maybe Viarac, we're onto something. But at the end of the day, 2.6 millimeter port, I personally won't go over a 3 millimeter port. I like 2.6 to 2.8 millimeter ports, and I leave them there for good reason, and that is because the barrels are machined like this, which means that the pellets let go sooner in the firing cycle, and if they go too soon, they never get the pressure behind them they need. So leave the port alone if you can.